Hi everyone, welcome. Today we explore how design thinking enhances material testing for aircraft structures. Through brainstorming with the two students, we'll connect real world needs to innovative solutions, uncovering how engineering and creativity shape aviation safety, efficiency, and future advancements. Let's begin.
Professor, we have been learning about material testing techniques, but today we came across the concept of design thinking in engineering. How does it apply to material testing for aircraft structures?
That's an excellent question. Design thinking is a structured yet flexible approach to problem solving that encourages creativity and human centered solutions. In material testing, it helps us approach challenges in aviation with a focus on safety, efficiency, and cost effectiveness. It ensures that materials are not only tested for technical performance but also with their real world applications.
So instead of just testing materials for strength, we also consider how they impact the aircraft and the people using it.
Exactly. Engineers need to consider how materials interact with the various stakeholders. Um, for example, pilots, passengers, manufacturers, and maintenance teams. This approach helps us develop solutions that address practical challenges such as reducing the aircraft weight without compromising durability.
The first stage of the design thinking is empathy, but how does empathy fit into something as technical as material testing?
Empathy means understanding the needs and the experiences of all stakeholders involved in aviation. Material testing is not just about mechanical properties, it is about ensuring the safety and the comfort of those who rely on those materials.
Can you give us some real world example where empathy shaped material testing, sir?
Sure. Think about aircraft cabin materials. Initially, engineers focused solely on the durability and cost. However, by applying the empathy, they realized that passengers needed a quieter and a more comfortable flying experience. This led to the development of lightweight composites that reduce noise, improve fire resistance, and enhance air quality.
So by understanding user needs, engineers were able to redefine materials requirement beyond just strengths.
Precisely, empathy driven design ensures that every aspect of material performance aligns with the real world applications.
After understanding user needs, the next stage is define. How does this help in material testing, sir?
The defense stage helps engineers frame precise and actionable problems. Instead of a broad statement like we need stronger materials, we refine it to something like how might we develop materials that understand extreme stress while remaining lightweight and cost effective.
This sounds like help focus research efforts more effectively.
Absolutely. A well defined problem ensures that engineers target real challenges. For example, when traditional reverted aluminum structures developed micro cracks over time, researchers redefined the problem as how might we develop the materials that resist fatigue while reducing the maintenance costs. This led to the adoption of composite materials and advanced bonding techniques.
Now comes the exciting part, ideate. How does engineers comes up with the innovative testing approaches, sir?
In the ideate phase, engineers brainstorm new ways to test and improve materials. Traditional methods are useful, but innovation often comes from thinking outside the box.
Can you share an example where ideation lead to major breakthrough?
Certainly, one major breakthrough involved self healing composites. Engineers observed that while carbon fiber composites were strong, they could develop microscopic cracks that weakened them over time. By applying the design thinking, they explored embedding microcapsules into the material. When a crack formed, these capsules released a healing agent that sealed the damage automatically, significantly improving the material longevity.
That's incredible. So ideation helped engineers push beyond traditional repair methods.
Exactly, innovation in testing leads to innovation in materials.
Once engineers have an idea, they move to the prototype stage. What does it involve in material testing, sir?
Prototyping involves creating small scale material samples and subjecting them to controlled test. This stage is crucial because it allows the engineers to refine the materials before mass production.
What are some of the latest prototyping methods being used, sir?
3D printing and AI driven simulations have revolutionized prototyping. With the 3D printing, engineers can quickly create and test material samples. AI based simulations, on the other hand, can replicate years of stress testing in just a few hours, accelerating the development and reducing costs.
That means engineers can iterate much faster, improving materials before they reach full scale production. Sir.
Exactly. Rapid prototyping is a game changer for aerospace engineering.
After prototyping, we reach the test phase. How do engineers ensure a material is truly ready for use?
Testing is the most critical phase. Engineers expose materials to extreme conditions, high temperatures, pressure, corrosion, and impact to verify their performance.
Can you give us an example where rigorous testing was crucial?
Absolutely. The space shuttle's thermal protection tiles were subjected to test replicating the re-entry conditions exceeding around 1650 degrees centigrade. This extensive testing ensured they wouldn't fail during flight, making space travel safer.
So, without testing, even the most promising materials could pose risks.
Correct. Testing validates whether a material meets all safety and performance standards before it is used in the real world applications.
It seems like design thinking has transformed material testing. What does the future hold, sir?
The future will see even more AI driven predictive testing, real time structural health monitoring, and self adapting materials. Engineers will continue refining these methods to create smarter, more resilient aircraft structures.
This discussion has changed how we think about material testing. It's not just about experiments but an entire process of innovation.